have three speakers. The last one, Lucas, will not be here with us, but he has recorded a video that will be presented in due course. Probably we will end the session a little bit earlier than scheduled, but that's okay. That will give us more time for the closing, so no problem. Even so, we have started with 16 minutes delay, so. Yeah. Or if you want, Christian and Didier, you can add a few minutes to your talk. Just a few. So, let's start. And first we will have Professor Didier Covas, the head of CIRIS. CIRIS is a research unit from Instituto Superior Técnico operating in the civil engineering area. So, Didier, you can go. Yes, thank you. No.
Thank you very much. First, it's a pleasure to be here with my dear colleagues from LNEC, with my dear friend Helena Alegre, with whom I've worked so many hours, writing books and working in projects. I must say I've learned a lot with this group, with the group from LNEC, and I'm very grateful for everything I've learned with them. I'm here on behalf of Técnico, Instituto Superior Técnico. Instituto Superior Técnico is a faculty from the University of Lisbon that I will present you and give you some numbers about. This is the structure of my presentation. I'll start with an overview of Instituto Superior Técnico, then I'll talk about the research units, and then I'll go further into detail about higher education programs in the context of water scarcity and floods and extreme events, and also present you the research lines and the developments that we have been doing in this context. So starting with Técnico. Técnico was created in 1911. And it became later a school, the Engineering and Science and Technology School of Technical University of Lisbon. More recently, the Technical University of Lisbon merged with the Classical University and it became the University of Lisbon. So it is one of the faculties of the University of Lisbon. Técnico has the mission to contribute to the development of the society. We serve the society, and through what? Through providing higher education and carrying out research in different domains, in engineering, science, technology, architecture. We've got 3 campi, one here in Alameda, one in Oeiras, and one in Lourdes. Just some figures to know the size of Técnico. These figures are from 2021. At least they are accurate from that date. We have 11,000 students spread between undergraduate programs and master and PhD programs. So around 56% is bachelor programs and 44% master and doctoral programs. We have around 30% of PhD students, international PhD students, but we don't have many international students in the undergraduate and master courses. We offer, in terms of education, higher education, 84 programs, 18 in the first cycle, 33 at the master level, and 33 at the doctoral level. In terms of people, we are around 1,300 people, spread between faculty and staff. Staff, we have administrative staff, technicians, and researchers. In terms of research, we have around 720 PhD students, and we are enrolled in over than 1,000 R&D projects. So Técnico is a very large, big institution. We have several international partnerships and some numbers about the employment of our students, and we are very happy for this. Around 46% of our students are employed before they finish the graduation, and over than 87 are employed 6 months after graduation. So I would say that students from our institution are very successful in terms of finding the employment. So this is Técnico. Technical research activity is organized in centers and institutions. We have 23 research units, and some of these units, all of these units, we have all the logos from these units, some of them are organized in associated laboratories. This is just for the question of funding. For the national funding, it's convenient for some of these institutions to merge and work together, collaborate, and create associated laboratories. The research is organized in 7 scientific domains. This is just to give you a perspective how broad is technical in our research. 7 scientific domains: basic sciences, engineering, production and technologies, energy, environment and mobility, information, communication and technologies, technology management and entrepreneurship, applied life sciences and materials, microtechnology and nanotechnology. Very, very broad scope. When I look further into detail in the subdomains that work in water scarcity, floods and extreme events, I found out these 3 scientific domains. And when I zoomed a little bit more, I found 4 research units working in these areas. I must say that this was a hard task because I had to do a bottom-up approach. We didn't have the idea who was working in what, so I had to ask to the central services to find out for projects and for people working in these areas. And we came up with 4 research units working in this thematic area. The largest one is CERIS. CERIS is the Civil Engineering Research Institution, the one that I'm the head of this group. It has around 350 people. Then we have SERENA. SERENA is the Center of Natural Resources and Environment. Then we have SITUA. SITUA is the Territory, Urbanism and Architecture Center. And finally, we have MARTEC, which is the Center of Marine Environment and Technology. So these 4 research centers working in this thematic. So this was, as I said, a bottom-up approach. In this context, I found out that we have a couple of higher education programs at the master and doctoral level focusing on climate change, extreme events, sustainability. And I bring you here what I have collected, and which I think it's important. We have 2 doctoral programs in this topic. The first one is Climate Change and Sustainable Development Policies. This doctoral program was created over 10 years ago, and it is a joint program between 3 universities: University of Lisbon, Nova University, and University of East Anglia. It's a 3-year duration, and it offers different courses in social sciences, physics, natural science, engineering, and engineering. But it awards single degrees, so only one of these institutions awards a degree. The second doctoral program that we have is Sustainability Science. This is a more recent doctoral program that we have created. It involves 17 faculties and institutes from the University of Lisbon. It also offers a diversity of courses related to resources, food, society, etc. And as I've said, it's focused on sustainable development. Then we have a very successful master program, which is the Erasmus Mundus Groundwatch program. This is focused on groundwater and global change. It had 3 editions. It funded 15 master students per year, and it is a program that operates during 2 years and involves 3 universities: Lisbon, Delft, and Dresden. This is very successful, and it will start a new edition in 2024, next academic year. And then we have other programs that aim to strengthen our curricula, what we have, and aim as well to train the staff, to train people to give lectures and better lectures. And we have two programs in this context, both funded by the Erasmus And as I've said, they aim to promote education in these domains. The first one is in water resources management, aims to develop new curricula, new master programs in the field of water resources, to design and to upgrade several laboratories in the Western Balkan universities, and to implement new learning courses in the water sector. This took place, this finished last year, and there was another program similar to this one that was applied to the Mozambique area. So it was aimed as well to develop new courses. In this case, focusing on disaster management using geospatial information, and it aimed to train faculty members from Mozambique. It was implemented in universities of Mozambique at the master level, and it is finishing this year, this program. This year we were very successful with one Marie Curie doctoral network that we just started this year, which is called Green Nexus. It is in the area of architecture, and it also addresses issues related to planning the city, promoting the development of the city, addressing issues like climate change. So this is a program that will start this year. So this is in terms of our higher education programs. In terms of research, as I've said, I had to do a bottom-up approach. So I collected lots of information about different projects that were carried out in the 4 research centers, and I categorized them in these groups. And what I'm going to show you is organized by these research lines. So water resources management, groundwater management, monitoring and mitigating desertification, promoting the sustainable soil conservation, and then practices related to the efficient water use and the integration of reused water in the water cycle. And then finally, the last 3 topics are related to flood management, flood risk, inundation, contamination management. And the way I've organized this, for each of these research lines, I'm going to show you the developments, the projects, and the developments that we have carried out. These projects, most of them have been reported to the last 5 years, because it was the information that we had, and that it was possible also to collect. Starting with water resources, we found out 2 projects that very much focus on the development of platforms. So we have, in our projects, we have 2 approaches. Either we develop platform software applications to facilitate the engineering analysis, the research, or we develop methodologies. These 2 projects are from our center, CERIS, developed by the Civil Engineering Group, actually by the Hydraulics and Water Resources Group from our department. And the first one was focused on the resilience of river ecosystems. So what have they developed? They have developed what they claim it is a high-resolution monitoring and warning system applied to rivers that integrates different tools, modeling, forecasting tools, and planning tools. And they have applied this warning system to several case studies that were in the project, and tested in this scope the results of several nature-based solutions in degraded zones. Also in the water resources management, it was the same group, and this second project was a follow-up of the previous one. They sort of overlapped, developed a platform, a water resources management platform. Platform is application, software applications, and they have applied it to the Sudware region to study what were the water needs in this region during water scarcity periods. What they have developed are a set of tools that were merged in the platform, and these tools allow them to simulate different scenarios, future scenarios, and also has some features for the representation of the results, the spatial representation of the results. This is an example of a particular parameter that has been represented using this platform for water resources management. Also, in this context, I found out another project that focused slightly a little bit on the side, which is the management of the water that is stored in reservoirs for irrigation purposes. This was not carried out in Ceres, it was carried out in MARTEC. MARTEC is the other research center. And once again, it aims to be a high-resolution model, high resolution that presents a set of results from hydrological and as a result of hydrological and meteorological models. And this tool allows also to forecast the inflows, the outflows, the levels in the reservoirs, in these irrigation reservoirs that were studied. And they have applied this to 2 reservoirs of Surraia River Basin, which is a large area for agriculture irrigation in Portugal. The second research line is groundwater management. Groundwater is an issue that is treated by the other center, which is SERENA. SERENA is the Natural Resources and Environment Center. They are very much focused on this groundwater management and in the development of sets of tools to facilitate the treatment of the big data, the big hydrological and meteorological and all the data they can collect. So what they have done was they developed a platform that they say it's a cloud computing platform to process data, to process environmental open data, and to prepare it to be used for different purposes. They have applied it to groundwater modeling in Técnico, because these projects, all of them have the participation of Técnico, but Técnico only develops a part of the project. And the contribution was of the Técnico was on the groundwater area, and they have used this platform to combine numerical models of groundwater with citizen observations that were input into the model to better monitor the groundwater bodies. This was one platform they developed, and then they continued the developments because this is a sequence and the group is the same, it's the same people that continue working. They developed other groundwater management tools and applied them to simulate different strategies related to the groundwater management, and apply them to different case studies, what they say it's typical case studies in the Mediterranean area, and they use them for simulation. So both of them are tools. The first one to treat huge amount of data that is available and making it easier to be used for other purpose, and the second one is groundwater management tools. SERENA acts a lot in groundwater, but also focus the research on desertification. And so they have developed one tool, they call it Desert Watch, which is a tool for monitoring desertification. So what this tool allows, this is some plots of the tool, allows to collect and process data related to desertification and to the parameters that allow to estimate and to study desertification. And this model not only treats data, input data, but also results from simulations of models used to simulate different scenarios. Because this was an international project, it was applied to the different case studies of the partners, Portugal, Italy, and Turkey. This project continued, and it was followed by another one in which the tool, Desert Watch, was extended with new methods to integrate more data and to allow to add more variables and to allow a better representation of the results. And this was applied to a different case study, which was the Southern African region. Another topic that we have carried out research in this context of the water scarcity and floods is related to the soil conservation. This is the focus of a different center, which is MARTEC, and MARTEC developed 3 projects, sequential projects. I don't have the dates of the projects here, but I can say they were follow-ups of each other in different European programs. The first one was to develop the first tool, a WebGIS platform to monitor soil salinity and to evaluate, to assess the soil degradation risk. The second one, they applied the same tool and then they extended the tool and applied it to further analyze the desertification and to compare different practices, different agricultural practices. And the last one was a continuation, as I said, of the previous one, but also always in the scope of the conservation of the soil and the application of the best practices to have a sustainable agriculture. Then it comes 2 topics that are carried out in SERIS. The first one is related to promoting the efficient use of water. In this context, we have developed methodologies and have implemented, once again, platforms, decision support tools, because if we don't have tools, we cannot apply, we cannot test and make our methods available. So we developed platforms that allow a better management of water distribution systems. The first one was SEED. SEED was a project. What I'm showing you is some screenshots of SEED. The SEED is a platform that processes data, calculates key performance indicators associated with water distribution systems, and also allows the calculation of water and energy balances, as long as we input the data of the water distribution system. And this was the first project, was carried out at a national level. In the sequence of the SEED, we developed Wisdom. Wisdom is a platform with more tools. It has, apart from the previous ones, has got another tool for the optimal sensor location of precious sensors in the network to better detect leaks. We have a tool for anomaly detection, so it analyzes processes time series to detect sudden changes of flow that can somehow indicate a burst or any other anomaly in the system. And we have other tools for the burst location and the size estimation of a burst. All these tools were tested with case studies from Portuguese utilities, and what I'm showing you is some screenshots of the application of these tools. Then we also have another research line which is related to the efficient, it continues with the efficient use of water. This is another project, Aqua, that focused on the efficient use of water and energy in urban green spaces. I was involved in this project, and in this context we sort of replicated what we were doing in water distribution systems and applied them at a smaller scale, a scale of the green spaces, the scale of the garden. So we have developed new water and energy balances specific of gardens that we call the green spaces, and we applied this to 3 types of gardens: an ancient garden, an urban park with a traditional irrigation system, and a modern garden with a smart irrigation system. And this is the classical garden, some pictures of the classical garden. We use numerical modeling to simulate the networks. And the final conclusion from this project, apart from all the developments that we have done and the balances, the water and energy balances, was that ancient gardens were very efficient because the vegetation it was in these gardens was much less water demanding than our current gardens, than the gardens that we have nowadays. And we also came up to the conclusion that when we have a smart irrigation system, we can reduce up to 50% the water consumption in the gardens. And this was based on real measurements, because we had a situation to compare before implementing the smart system and after implementing the same garden before and after, and we came up with 50% saving of water. Also in the line of water, we have the promoting the integration of reused water in the water cycle. And in this area, what we have done, and this was both at, this is wrong, this is both at Ceres, this was at Ceres and Situa as well, is we have studied different nature-based solutions for integrating grey water or storm water in the urban water cycle. There were two projects related to that, Twist and Genesis. And in the first project, we have created a living lab in Técnico in our campus of Alameda. This is a green wall in which there are these plants that are irrigated with grey water that is collected in the toilets. And there is here a storing system of the grey water that we take there. So we collect in the toilets, we take to this small tank, and then there is a pump that pumps water to irrigate this green wall. And so this was it's something that we are very proud of, because it's something that we could do at our campus and implement these small pilots to demonstrate the efficiency of these green walls. Also related to green walls and to green roofs, there was this second project that didn't focus on the technical part, testing the solution, but on the benefits of using these solutions. Benefits from the point of view of environment, economics, and social benefits. This research was not carried out by hydraulic engineers, but by other colleagues of our group from economics. So their perspective was slightly different than ours. It was from the point of view of cost-benefit analysis of the implementation of these solutions, and they have analyzed different combinations of solutions to come up to what was the best one. The other research line is related to inundation and contamination management. This was carried out in Martech. Let me just put the film while I'm talking. In this project, which was called AS Runoff, it was developed a framework for early warning, detection, follow-up, and early response to different floods and to different hazard material pollutions in the inland and in waters, coastal waters. And this framework combined different sorts of data and results. The first one were in situ measurements collected by sensors installed in situ. It combined remote sensing technologies like drones and satellites. What I'm showing you is an image collected by a drone. And it combined also with results from complex numerical models that combine the surface flow, the drainage system flow, combine the hydrological parameters, everything. They call it holistic models, which combine different models in a single model and run all the models simultaneously. And this tool was tested for different case studies. It was applied to Sacavém, Loures region. This is what I'm showing you. And this is the result of MOID land and SWIM, which is the surface flow and drainage system flow, simulating a flood together, both running together. Actually, they are not coupled. They run together. At each time, they switch between one and the other. So it's not a fully coupled, but they simulate simultaneously. And so this was run by Martech. A project that also used the same model, and I think that LNEC was also involved in this project, is Synergia, in which it aimed to develop once again a platform that helps decision making in the use of resources and emergency management of inundation and contamination in coastal areas. This Synergia was focused in a certain urban drainage basin, the one located in Albufeira and Quarteira. This is an example of the infrastructures, the drainage system and the surface that was used to was simulated in this context using humoid land and swim. So it's once again the same model that I showed you the dynamic film previously. So they also simulated the case study. And this project also allows to estimate the propagation, the dispersion of the contaminants. And here is an example of a surface concentrations of E. coli at 2 times of the day, 6 in the morning and 12 in the morning, after having had a contamination in the coast. So this was what was developed in this project. Then we have a quite different approach, the group of Situa. Group of Situa is a group of architects. They don't develop numerical models, they don't develop platforms, and the way they approach research is slightly different. But they also address floods and risks in what they call urban waterfronts. And they have applied this risk analysis to the wavefront of Tagus Tuari, in which they have identified what were the strategies, the policies, the projects, the programs that were associated to these front lines. They analyzed, this is, as I said, it's not engineering, it's not calculations, it's completely different. So identified the list of strategies, projects, etc. They identified all the stakeholders, the key stakeholders that were affected by these front lines, conflicts between them, their perception about the risk of these front lines. They collected information with the public to better understand what was their perception about eventual interventions that were in this coastal line, and they carried out this critical analysis. And based on this, they identified a set of actions that could improve the development of this front line. So it was like sort of very brainstorming, interacting with the public, identifying the perception of the public. This is something very important that sometimes we engineers tend to neglect, is to enroll the public in the development of the city's thinking, improving the solutions of the city. In the context, continuing the floods, we have more projects, projects related to, once again, platforms, models, to analyze risks, propagate risks. The first one was combined, it was focused on landslides. So what they developed was a methodology, and they implemented a tool for collecting data on landslides. They call it inventories of landslides. And it combined remote sensing from satellites and aerial images with elevation and field data, with high spatial resolution. So they wanted to learn about the occurrence of these landslides based on observations and create a large database. They tested this in Madeira, in Funchal and Ribeira das Bravas basins. This is some example of the landslides caused by flash floods in 2010. AGEO was another project that also was collected data, and this was a platform focusing on several cities and observations, pilots on Atlantic geohazards. They included several geohazards, landslides, floods, flash floods, earthquakes, rockfalls. They enrolled the community to collect data, to more actively contribute to this collection of data with pictures, photos they sent and they uploaded in this platform. And the idea with this project was to establish recommendations for the creation of other future observatories in geohazards. And then we have two more projects also related to flood risk, SCORE and River Cure. The first one focused on development of technologies and solutions, and the second one on mathematical models. Not only hydraulic models, but also morphodynamic models applied to rivers and during the occurrence of floods or other situations. This model of River Cure, it's like, as I said, the follow-up of previous models that we have developed there. And what I'm going to show you is something very interesting to show the application of this model. This is part of a film that was a result of numerical model calculations. What I'm going to show you is the recreation of the 1755 tsunami in Lisbon, but in the Lisbon of nowadays, our Lisbon today. So,
Permite avaliar a severidade da ação.
Sorry, I want to take the sound because I'm going to explain. It's in Portuguese and I'm sorry. So, this was the tsunami. The tsunami flooded the coastal area of Lisbon, and this is the flooded areas. So this is numerical simulations with the same model I told you about River Cure. This is Praça do Comércio. This is the line of cars. There was a traffic line here, and this is when the tsunami occurred. The cars were spread all over, so we could no longer see the line. So this was the effect of the tsunami on the cars. I think this gives us a perspective of what the impact of a tsunami would be nowadays if we were in this traffic line here. So basically this is one of the applications of that numerical model. Just to finish, because I'm taking a lot of time, I'm going to just, I have some insights about what I think in this context, based on my experience, what are the future challenges in the context of water scarcity and floods and extreme events. I think the first challenges are related to sensorization and digitalization. Technologies are developing very fast, and I think that in the near future we will have very advanced sensing technologies. We will have the in situ sensors, low-cost in situ sensors, efficient, autonomous, with less battery demanding. We will have drone satellites that we already have. We have video cameras, and we will also have opportunistic sensing, people taking pictures and uploading them in databases. So the challenge will be using these technologies, integrating them all together with the numerical models in platforms and in tools that can help us to better decide. The second challenge is because we collect huge amount of data, we will have difficulties in understanding this data, in processing the data, extracting knowledge from the data. So I think here machine learning and AI will help us a lot, but there's still a lot to be done. And when I'm talking about data, I'm talking about not only series of data, but also images. So the role of this machine learning treating the data. The other point, which is also related to digitalization, is the further development of these complete numerical models that integrate different systems, the meteorological parameters, the hydrological, the surface flow, drainage systems, pollution dispersion, like the one I've shown you some in the previous slides. but further developed and connected with these multiple sensing technologies, not only for simulating and predicting in real time, but faster than real time. This is the point. We must anticipate what is happening, so we will use all these models, all this data all together, and faster than the reality, we can predict what is happening. And finally, I think we can test all these tools, all these technologies and solutions in living labs. We have very recently applied to a project to implement a flood risk monitoring system in the green-blue corridor of Jamor River. So Technic is involved in this project, and we aim to test the technologies there if we are successful with the project. So that's why I truly believe in these living labs as the first step to apply these systems. In terms of water scarcity and extreme floods, more specifically, I've got 2 points or two for the water scarcity. I think we need to increase resilience to water scarcity. It's inevitable. We will have increasingly more droughts, and we cannot run from that, and increasingly more floods. So we have to think ahead and think and take in advance measures and prepare ourselves. And I think 2 lines that we should invest on is, the first one is to better integrate non-potable water sources in the water cycle. And I'm thinking in all types of water: treated water, grey water, storm water. We can use, for instance, this treated water to recharge aquifers. We can use grey water or eventually treated water for irrigation of green areas or street washing. So it's the better use and the more intensive use of these non-potable waters in the water cycle. And the other one is, because we have all these new water sources, we may have to redesign and to rethink about our water distribution systems. We no longer need one single system. We may need dual systems, one system with drinking water and a parallel system, at least in the main lines, with this treated water for other purposes, for other uses. And I think we need to rethink the way we distribute water to our cities. In terms of floods, I think we are on the good way to implement nature-based solutions to mitigate these urban floods, but we may have to rethink and redesign our cities to increase resilience. Now everyone talks about sponge cities, cities with lots of green spaces where the floods can infiltrate. So I think this is another point, and it's not just from the engineering perspective, but we also have to add here other competencies: architecture, territorial planning, integrate several, as I said, areas in rethinking and redesigning our cities. And finally, I very much believe that we can reach one day we can develop very effective and efficient flood monitoring, prediction and warning systems. I can say that in these days I've received several warnings in my mobile saying that there was going to occur a flood now in Lisbon. Be careful in the next 36 hours. Actually, it rained a lot, but there wasn't that much a flood. But anyway, I very much believe in this, and we can improve, and we can, as I said, a step ahead of what is going to happen to predict what is going to happen. And so this is it. I just want to thank to Marta that has helped me with this presentation, and to all my colleagues from the 4 research centers that have provided data and that have participated in these projects, without whom it wouldn't have been possible to be here and presenting this work. Okay. Thank you.
Thank you. Just to say, yesterday we tried a beer made with no potable water. So, Vida.
I've heard a lot about that beer.
It was good.
The first time I had that beer, it was the first time they organized the session in Águas do Tejo Atlantic, probably 4 years ago.
Yes, 2019 it was when
it was
they
2019.
Started, yes.
They also served. At that time, I didn't believe it was with with reused water.
Yep.
Treated water.
But it was not.
I thought it was just, but actually it is. As
Yes,
they
it
claim.
is. Yes, yes, they explain it. So, any question to Didier? Yes, Ioana?
Well, very well done, Didier. It was really a lot of work. You did it very well, and so no surprise that many of the ideas you put here as challenges coincide with the ones we have. And I'd like to ask you two very different questions. One more technical, one more approaches. You know LNEC quite well. We know, well, each other, not only you and me, but the teams, we know each other, the group. So we know what are the strengths and the weaknesses of each one organizations. So I'd like to have some quick thoughts, not only for us, because we know, but I mean, collaboration between research laboratories, more the style or research institutions such as LNEC, but not only LNEC, our case, and universities, knowing the differences.
And the complementarities.
Well, I'd like you to mention from your point of view what are these complementarities, how we can really, why we are all time coming to each other and working together, why, so I'd like to have some thoughts from your side on that. Not limiting to us, but, well, broadening up and, so this is one thing. The other thing is more technological. So you mentioned about the lots of data, the low quality, no, sometimes low quality.
No, most of the times.
But low cost censoring, the massive centering. So I fully agree with what you say. But I have a kind of fear of this, is that we have so many data. We process, it's a kind of chat GPT. Then the replies sometimes seem to be real, even though they are not. So my question is, aren't you afraid of some false intelligence that is, don't you think that there is a risk of people seeing so many fancy things, so nice graphs, so nice interfaces, so logic, apparently logic responses, that we believe this is the truth, and sometimes we forget. I have seen sometimes some explanations based on artificial intelligence that I said, but you aren't you an engineer? Don't you have the basics to understand that this is a nonsense? So I'd like you also to mention this potential negative side of this massification. Although I agree with what you said, but I think we cannot forget the other side.
So starting with the first question and thinking for the particular case of LNEC and Technic, which is easier for me to think, I think we are very complementary. On one side, we are the university, we have students, we have opportunities, so we can bring the students when we can work together, not only at the master but at the doctoral level. But sometimes we tend not to have so much contact with the industry. And sometimes we develop much further numerical models, more theoretical things. When we work together, you bring the concerns from the industry, from the society closer to us, and we together, and you bring us also the opportunities to work with the industry, with the utilities that we don't have, because you work, in part of the time you do consultancy works for them. So I think the complementarity is, on one side we are more theoretical and we have the students, and we come to you and you have challenges from the society closer to her. You can help us to get closer to these utilities. And as I said, we increase the competencies. And the other thing is we have different perspectives of the same problem. Sometimes not the same. And this can bring another view to the problem. I must say I very much like to work with the group of NES and not only from the water distribution group but also for the drainage group and not the water quality group because I don't work in water quality, but I know Maria João, but I must say that it approaches us closer to the society, to the reality, to the real problems. And we tend not to be creating models and things that we cannot actually apply. So we tend to solve problems of the society. This is what I find when I come to you and I work with LNEC. Concerning the risks of AI and all these technologies, it is a risk. When we do all these tools, all these beautiful tools that plot graphs and things, they can provide fake information, definitely. And mostly because when we look at all this data, we look at the data and the data is full of mistakes, of anomalies. And if we simply treat the data and plot the results without looking at the raw data, this tends to happen. So we've tested this with these platforms because we have used this raw data and I must say that we collect data, but much of this data is bad quality data. It's very bad quality data. Anomaly values, zero values, very high values, and it doesn't represent the reality. So there is a risk, but we must learn with that. We can use machine learning to learn what is wrong and what is right. I don't know, probably this is a way. I'm not sure. I like to think we may be able to do this. Machine learning may help us, but we run always the risk of that, of getting fake results and a completely different perspective of what is the reality. And this is a risk that we run. That's true, Elena. And who deals with data, people who deal with data know this.
Okay. Thank you, Didier. We have to move on. So probably we can discuss more in the closing session also, but for now we have to move on. So now we have Christian Stem. He has been introduced this morning, but he is the Deputy Director of EAVAC.
Okay,
so please.
Thanks. So thanks for the endurance that you show and still share some minutes with me to present some experiences from our side. So I'm happy to have been invited to learn a lot about conditions where I'm not very familiar with. So let's see. I hope that some of the input that I can share with you is also valuable for you. And I would like to write at the beginning, acknowledge, I don't have a pointer here, the co-authors, several people, including João Leitão, who is here in the audience, helped me with preparing the content of this presentation. So EAVAC, so this is the Swiss Federal Institute of Aquatic Science and Technology. I learned it's more or less the same size as LNEC, about 500 people working on that in our institution. Water is at the core, of course, of our institution, but it links many themes. I have not put up the names of the departments. We have 12 research departments. I grouped them a little bit. So you see we have a large range of topics, disciplines that we cover. So we are not a civil engineering institute. We have a broad range of competencies. So we have engineering, process engineering, we have the urban hydrology department, but we also have ecology, environmental chemistry, but we also deal with sanitation and water for development in the global south. So we have quite a range of disciplines, and this is also core of our kind of culture that we try to develop. You can imagine extreme weathers, floods, droughts, they all impact these water-related aspects that we work on. And you may ask, okay, Switzerland, sometimes that's called the water tower in Europe because we have some major floods that originate, that have their sources in the Alps in Switzerland. So why do you care? For example, with regard to droughts, but this is a picture that was published in newspapers last year. So we have many alpine meadows but if you have to bring up water for watering the cows up there, that's not a sustainable solution. So we also need to think at least on seasonal drought conditions. Okay. Yeah, helicopters aren't the solution. So what I'm going to do now, I try to provide you a few glimpses on what we are doing at ERWAG with relationship to floods, droughts, and extremes. I will talk about urban systems, but also natural systems. You will hear some repetition of what other people have many times already presented today. I try to keep it short. The water management that links extremes, drought, and floods will be a little bit of a topic. I will talk about the protection of humans, but we also would like to see, okay, what does this imply for the conservation of ecosystems? Ecosystem services have been mentioned this morning already. And I think our part from the science, the research is that we can provide technologies, new scientific methods, system designs options, but very important to us that we do that in co-creation with stakeholders. And I briefly come to that with one or two examples. I start with a flood pictures. I'm very brief on that. We all heard about that, yes. These kind of events, they will increase in the future. And one of the issues that we have to face is that the changing climate hits our kind of infrastructure that we have built in the urban, but also in the rural areas in the mind of a past kind of climate. So here we have a discrepancy also with regard to temporal evolution. Okay, now we have this infrastructure that has been built based on past experiences, and the question is, okay, how do we cope with that? And one thing, yeah, they are conflicting, so yeah. So one thing is to actually to say, okay, at the moment we need to live with what we have. We can't change that instantaneously, so one way of moving forward is to say, okay, at least we should, for example, improve our warning systems. For example, to have the possibility in cities, in urban areas, to have nowcasting so that we know and can warn people, okay, these parts of the city may get flooded in the next minutes or a few hours. And Joao is working on that. He tries to tackle some of those challenges. So we need to have a high resolution image of the surfaces. We need to have a very fast processing of complex models, because otherwise we are too late. And of course, you would like to also calibrate the models before you implement them as warning systems. So you need to have also spatial information, for example, in an urban environment about water levels and so on. And often, as mentioned before, we have kind of poor data, but still they may contain important information. So using proxy data, even yeah, social media, pictures, whatever, can be useful to combine into an effort to provide reliable warning systems. Okay, this would be one aspect. Okay, we do the best that we can with what currently is, for example, on the ground or below ground. But then, of course, and this has been alluded to several times during these 2 days, is we need to think about, okay, how can we redesign the system as it is? So, and of course, the retention of water, and there's the term sponge city again, okay, we try to keep the water for some time when it's raining, and we dampen the temporal fluctuations of water fluxes. Okay, that's basically the idea behind sponge city. So we retain water with different blue-green infrastructures. We will see some more pictures of that. This, of course, has also then, if we move to the dry weather conditions, where we also might have water scarcity, to the effect that we can reduce heat in cities. With blue-green infrastructure, we potentially can increase the biodiversity in the urban environment. It can contribute to energy savings because we need less cooling. We potentially also retain pollutants in these kind of infrastructure. So this is an additional service to the receiving water bodies. And this, for several reasons, improves human health. There's a whole set of potential blue-green infrastructures. You see that on this slide. I don't go into the details. Probably the slides should get available after the conference, I was told, so you can have a look there if you wish. So what we do, part of the research that we do related to that is to have experimental but also model-based investigations on individual structures, so retention structures, green roofs, etc., to see what are their effects with regard to water balances, heat exchange, and so on. And of course, if you have these blue-green infrastructures, they link the rainy conditions with dry weather conditions. Another aspect is, okay, we have those, let's say, concrete examples where we experimentally measure, but we perhaps would like to have the possibility to assess the effect of these kind of infrastructures at a larger scale in space, but also over time. And remote sensing can offer us possibility to actually do that, to look also into the past, so look into conditions where before blue-green infrastructure was implemented in place, and then see how those effects turn out over time. And schematically, I hope I managed that, to show that. So one possibility is that you follow over time the development of certain pixels that represent blue-green infrastructure. You look at how surface temperature is evolving over time. You can look at the greenness, so NDVI indices, for example, to see how the vegetation evolves and what are the relationships. And just again, from Joa's work, one example. So you see here on the left-hand side, the city of Zurich and some locations where different blue-green infrastructures were investigated over time. I show here two examples, short vegetation in the top panel and a blue-green infrastructure where trees were planted. And if you look at the green line in the two plots, you can easily see, yes, if you have a short vegetation, the reaction of the implementation of this infrastructure is much more rapid because vegetation grows faster compared to trees, which take longer. So these kind of instruments then can also help us to go to larger spatial scales and also have access to temporal time series, for example. Okay. If we talk about water scarcity, water reuse is, of course, has been mentioned intensively for good reasons here at the conference. We also do work on that in the process engineering, where we try to develop systems that work under different conditions. And here, just with that picture, a first glimpse, also the only glimpse actually in this presentation. We all also work in the global south, where water scarcity for different reasons, not just climatic ones, are a big issue. And for example, we would like to, we provide the possibility that people have access, for example, to clean water for washing their hands, for hygiene. And we do that in a closed system, so that the water is treated again. It's through two biological filters, activated carbon and chlorination, to provide the people also off-grid with water for hygiene. But these kind of systems, they can also be implemented, or water reuse systems we work on are currently tested in Bangalore, which is the Silicon Valley of India. So people are not poor, but sanitation is kind of bad, and water conditions are also not very advanced, so we try to improve there. In a completely different situation, similar aspects are currently implemented in San Francisco. We do it on our campus. I come to that. So we have an experimental building with some facilities. But there are also sectors like, for example, trains, where we would like to have the possibility to wash our hands, and there you also could think about reuse of water with these kind of aspects. So these are a little bit bits of pieces. We would like to have a bigger picture and bring those different elements that could go into more sustainable cities, for example, into a larger, more comprehensive context. That's difficult to do as a research project. And therefore, there's the idea of those urban living labs. But these are, I mean, this is a kind of a fusion of real-world experiment and science. So this implies, and here, one example that I would like to mention here. So this is in the city of Bern, so the capital of Switzerland. They would like to develop an area for 3,000 people. And now, early on, people from EAWAG got involved with them and said, okay, we would like to develop that into a living lab for where you implement blue-green infrastructure. We would like to see what happens with water fluxes, groundwater recharge, and so on, biodiversity. And people were happy, but this is also a political process. So this implies it takes time. It's not our timing that guides the process. It's mainly a political decision how this thing evolves over time. And this has then strong consequences on how we can actually do our research and what it implies for the researchers. You can't say, okay, a PhD student is working on this urban living lab and having a defined research schedule. It will fail because the process is too slow. So we need to think about how we can do that. Now I make a big switch out of the urban areas. We go to the watersheds, the more rural areas. We have seen pictures of floods several times during those 2 days. And I would say we almost always looked from a human perspective. It's doing damage. We don't want to see those pictures. How to prevent that? From an ecological perspective, I would argue those floods, they are essential. We need to have them for having habitats, diversity of habitats in riverine systems. And we should not forget about that. And just two reasons why that's the case. The first is some of the organisms living in those rivers, they need to have gravel bars which are free of fine sediments. So if you only have constant low flow conditions, fine sediments will accumulate in those gravel bars. And for example, the eggs of brown trout can't survive. So that's really a problem. So you need to have this flushing. Even more so, if you have bad moving floods, this implies you remove and you restart a succession of terrestrial habitat in those rivers. And just to illustrate that with a time series of pictures, that's not from Switzerland, that's from the US, but the principle is the same. You see, if you look over a time series of decades, how the flow system, the river channels have been moving all the time. And this implies new habitat has been generated, regenerated. And this is necessary for healthy aquatic ecosystem, riverine systems. And then this, of course, poses a major problem. We want to protect humans, we want to protect our infrastructure, but we also would like to have healthy aquatic ecosystems. So how do we deal with the environment to bring together expertise from EAWAG, which is specifically in this case aquatic ecology, with engineering competencies from the two schools and ETH Zurich and EPFL, and also expertise from another research institute in our domain, WSL. And the idea is to really come up with practical solutions, science-based solutions, how we can manage river restoration under Swiss conditions. And I just would like to illustrate with one single kind of experiment what kind of research we do in this context and what this might imply for practice. So in Switzerland we have water is scarce, but what is even more scarce is space. Land is probably the most disputed kind of resource that we have. And if you talk about river restoration, this is often small scale. So what you see here is a small stretch, a river stretch in the canton of Bern. So the people thought we would like to restore this section to provide more space for the river. And then, of course, the question is, okay, how do we need to manage the river as well to actually benefit from the restoration process? And people, and here a very nice link to, I mean, that's a tiny bit of what we have seen in the excursion here. So the colleagues at ETH, they also have these kind of physical models, but here this tiny and small scale, but still it's useful. Okay, they worked on this river section and then also worked, of course, with numerical models. And the question behind that is to know what are the relationships between different discharge levels and also bed load supply to the river section to see how the widening of the river is actually explored. And very briefly, what you see here in a series of 3 panels, on the top level, you see for a flood of, I think it's a 2 or 3 years return period, the water distribution in this widening section, under the condition that you provide a bed load which corresponds to the transport capacity of the river at that discharge level. And then you see, okay, there's a little bit of meandering, so the water starts to fill the space. If you lack bed load, and you see that with a lower 2 levels, despite the fact that there's space, the water is still confined to the main channel. So one important conclusion, and this is important in Switzerland because we have many dams, many barriers that retain sediment. Without having an adequate bed load sediment input into the system, water is not just enough to have healthy aquatic ecosystems. Okay, we try to convert these kind of findings to practice as well through fact sheets, movies, interactive maps, workshops, of course, with people out there. And very importantly, these are long-term collaborations within the academic world, but also with the people, with authorities, with companies, and so on. So this is really, really essential. And with that, I'm coming to the last bit. So for us, it's important to do excellent research, and we put a lot of effort into that, but we also would like to have excellent impact. So part of that is that we also would like to show in the real world that some of the concepts that we work on really can be shown to the people. So for example, we have water reuse in our main building. So we collect the water on the roof, we store it here in these kind of ponds, and it's reused for our no-mix toilets. We contributed to river restoration that of a small creek that passes our campus. What you see here on the green areas, these are also infiltration areas on our campus. So if there's too much water that can be stored for water reuse, we let it infiltrate. So this is one part. So I was asked to come up with some challenges that I could highlight from our perspective. I think I don't need to mention climate change. I mentioned already, yes, we have a built infrastructure, so we don't have a greenfield approach to solve our problems. We need to think about, okay, how we can refurbish what we already have. And of course, if we do this kind of rethinking our infrastructure, so it's infrastructure, but we also have, let's say, kind of certain practices, how we do things, or we did things in the past. We have property rights and other aspects, social, societal factors that are kind of reflecting the conditions of the past. And we need to think broad enough, okay, how do we go into the future? And the problem is that we need to try to find and develop those solutions basically on the fly. And to be successful in that, I think it's really essential that we have processes where we co-create solutions with stakeholders and we have room for mutual learning. The transdisciplinary research has been mentioned several times. It's very important to us. Within our institution, we have natural scientists, engineering, social scientists under one roof. And this helps us enormously to really arrive at a more interdisciplinary approach in our research. I think real-world experiments like living labs are great opportunities, but they come with a number of challenges. And one of the aspects is the long-term perspective, which also requires you need to have that long-term perspective to build trust with people. You can't come and say, okay, I'm the expert and now let's collaborate. People need to trust you. And know, okay, if we talk with them, we get the responses that we need. And this implies that the people also in our institution, they have the possibility, their career path allows them to pursue those long-term commitments. We cannot allow just to think in 3 or 4 year projects. Of course, we do a lot of them, but we need to provide, and we do that, and we have the privilege to be able to do that for our permanent staff, that people can invest in these kind of long-term relationships, which implies that you go to committees which are perhaps not so beneficial at the short term, but over the years you build trust that helps you to implement a successful solution at a later stage. And with that, I thank you for your attention.
Thank you, Christian. Any question? Yes, Jean-Paul.
Well, we have been talking, and I changed the shirt. I was talking with my coffee burn, but in German. But I'm very interested on the relation that you have from research to innovation. We are doing, let's say, in Portugal, fantastic projects that I was saying to the minister, if this would be in Germany, in Singapore, in China, this airport that we have researched and done was already done. But here, sometimes from the administration, you are always skeptical. Looking to this building, if it was in LNEC, I don't think it would be able to be done, because somebody from the administration would come, are you sure that pollutants will not reach the underground or the aquifers? So how do you bring this novelty, this research, transforming this to innovation in Switzerland? So what you do, not just the committees, but how do you bring to see this is safe, sound, and sustainable? That's what we've been talking about, managed aquifer recharge. But it's not convincing. We still don't have it, and we are trying to force. And our parliament, and I was saying that yesterday, was trying to say to us, do implement this, please, last December, because groundwater, managed aquifer recharge, etc., reuse of water, because it's always some kind that's still something missing for us to trust you, and we have the National Water Council, the minister is there, you are able to transmit the stuff, I'm part of this, LNEC is also part, but it's always something avoiding you to put this innovation or this research into innovation. How you do that in Switzerland?
I would say as long as we are in topics which are not politically too disputed, we can be quite successful in being fast with implementation of novel ideas if we early on collaborate, for example, with authorities, and also address the potentially critical questions that may come from politicians, for example. So one example, so we have, in the meantime, this is 8 years ago, the law was changed in the sense that we have to have advanced wastewater treatment, an additional step, ozonation or powder activated carbon or something of similar effects on 120 of our 700 wastewater treatment plants. This happened within less than 10 years from, let's say, starting the research to the implementation by Parliament. It was a very intensive collaboration between the Federal Office of Environment and EWAG. We were able to demonstrate it works, first at small scale, pilot scale, and then full scale. And there it was also very important that the sector, the wastewater treatment sector, they were eager to take that up. They found, oh, cool, new thing, we improve on what we do. So, and also from the cost side, people say, okay, it's very expensive, but if you have a decent infrastructure, in our case, we would say 10 to 12 francs per year per person. We can afford that, okay? So there was not much political opposition, but still, if we had not gone that way with a very intensive collaboration with the relevant stakeholder, it would not have worked. Yeah.
Thank you, Christian. We have to move on. Thank you so much. So the last speaker, Lucas Repa, as I told you, he has not been able to be here, but he has recorded a video that we are going to play it now before ending this session. It's just a 7 minutes video, so. Sorry. So Lucas is a senior policy officer at European Commission.
So he's from DG Environment. DG Environment.
Yeah, DG Environment.
Hello from the European Commission in Brussels, and thank you very much for having me. It's my honor to speak to you today about water scarcity and droughts and what the European Commission is doing about it. Indeed, we are facing a triple planetary crisis, a crisis that affects biodiversity, a crisis that affects pollution, but also a crisis in particular about the unsustainable use of resources where water is at the heart. Due to unsustainable water management practices and climate change, fresh water is becoming scarcer in Europe. And when water is scarcer, pollution is less diluted, meaning that biodiversity, public health, and socioeconomic damages ensue. Sadly, we have seen this happening again this summer. Water scarcity and droughts made it to the headlines, followed by periods of flash floods, often in the same regions in Europe. The damages are significant. They amount to about 9 billion euros annually, and the latest predictions from the Copernicus Observatory suggest that in a 3 degrees Celsius warming scenario, annual damages from water scarcity and droughts could amount to up to 1 billion euros every year. Business as usual is therefore no longer an option. We need a systemic transformation of our systems, and we need to work together to achieve this. Ahead of the UN Water Conference in March last year, the European Council already agreed on a water resilience agenda, called for a strategic approach, and in June, the Parliament followed in a plenary discussion where more than 60 members of Parliament intervened to underline the concerns of their constituents about the decrease of water available to them and their economies. The European Economic and Social Committee very recently adopted 9 opinions on what they call the Blue Deal, which is nothing less than the request to adopt a comprehensive strategy for water in the European Union, which goes beyond what we already have today. Importantly, water scarcity is no longer a problem that affects the Mediterranean region and Portugal in particular. It goes beyond. Just today I've been speaking to water managers from the Netherlands, and the day before to water managers from the Flemish region of Belgium, and they are telling me that water scarcity is now also on the top of their agenda. It's not surprising, therefore, that Commission President Ursula von der Leyen announced in her State of the Union speech in September that we will adopt a water resilience initiative still this year in 2024. This water resilience initiative will build on the Green Deal. The Green Deal has done a lot when it comes to water. We have adopted several proposals for laws and the revision of laws, such as the Urban Wastewater Treatment Directive, the regulation on the sustainable use of pesticides, and the proposal to revise the list of water pollutants in the Water Framework Directive. The Commission has also adopted a number of proposals that affect the nature restoration and soil moisture in the Soil Monitoring Directive. We have revised the Industrial Emissions Directive in order to protect water that is used for industrial purposes and the eco-design for sustainable products regulation. Importantly, we are now at the moment very busy with reviewing the river basin management plans of the member states, which give us an idea about how far the member states have come to achieve good quantitative and qualitative status of waters. That's a very important exercise, and the last time around 5 years ago we have come to the conclusion that only 44% of the surface waters have reached good ecological status, and even less, only 31% of our surface waters reach good chemical status. This is really a big problem. When it comes to water scarcity and droughts, only 14 of 27 member states have a systemic integral approach to preparing for droughts in drought management plans. We need a more integrated and comprehensive advanced planning. But very importantly, and this is where the scientific community and where you all will come in, is the European Union needs reliable data. We need robust data to rely on to make predictions about the recurrence of droughts, which economic sectors they will hit, where they can be expected to occur, and more generally speaking, what is the situation of water scarcity, how much water is being abstracted from groundwater bodies, are ecological flows being respected in our surface waters and rivers. Data are at the beginning of everything. Good planning requires data. So when you're asking us what are the research priorities for the European Commission in the next mandate when it comes to water scarcity and droughts, my answer is it will be about reliable data. Now, the European Environmental Agency, the EEA, has already been at the forefront of collecting high-quality data, and we are grateful to our colleagues in the EEA for collecting data on the water exploitation, groundwater situation, moisture deficits, water abstractions, and data on the financial cost recovery of water services and the water availability. So a lot of the data that you see in the news come already from the EEA. But that is not alone, that is not enough, which is why the Joint Research Centre of the European Commission has been working with academics from all across Europe to create a European Drought Observatory. You may know it from the internet. It allows you to browse and to see where is there a high risk for agriculture when it comes to water scarcity and droughts. And this map will now be enhanced with a water impacts analysis where we see what the impacts of droughts are along the different value chains. The European Drought Observatory Risk Assessment is one of our latest and very important scientific projects to improve our database. But this is just the beginning. We need more reliable data to anticipate water risks. And we need data on the cost of drought risks, and we need data for improving the situation. So, long story short, Europe is at the beginning of a journey to achieve better water resilience in view of climate change, but also in view of man-made over-abstraction of waters, bad management of water, pollution of water, and scientific evidence, robust data will be at the heart of the strategy that we're going to roll out in the next mandate. And we do count on your support, ladies and gentlemen. So thank you very much for coming together here today. And thank you very much for working with us in Brussels, in the European Commission, on having the data and having the evidence that we need to make good policies for Europe. Thank you.
Okay, so no questions to Lucas. So we finish now this session. We are moving on to wrap up and recommendations. So thank you all for being here. Thank you, Didier and Christian. Thank you.
So, where is that? Onde é que ele está? Então, está aqui. Well, so really the last were not the least by no means. So we had really three great presentations, and I do appreciate once again the fact that to everybody who spoke here, and well, mainly those who came from a long way, they had to fly, and at least from our selfish perspective, it's very much worthwhile. I hope that you go back with the feeling that it was worth coming. We have just the feeling that we would like to start discussion, and time is as it is. So thank you very much for these great presentations. So now coming to the wrap-up and the recommendations, we would like to make it twofold. First thing, we would like to call of all of you to give us feedback on the list of recommendations that I showed yesterday. So I showed you a list of recommendations. So I'd like you to go to Mentimeter and rank them in some way. Say, to me, the most important of these 10 out of these 10 is this one. So 1, 2, 3, until the 10th. So I will go through that, and I will call for your participation via the Mentimeter. So the other thing is to collect in some way take-home messages from the discussions. Of course, this second issue is very much subjective, and what I did is, as sometimes there are some, well, when we are collecting funds from NGO or whatever, that we are, give me something. So I went to the moderators, I went to a couple of people and said, what are for you some take-home messages? And we didn't have the opportunity to do that on a systematic way to everybody. But so I collected these in this informal way, basically among the moderators, the organizing committee, and I'm going to show this collection, and I'd like to have your feedback and to say, okay, so this makes some sense for me, or there is a very important take-home message that for me I have in my mind and is not there, and we'll be glad to add to the final notes on this conference. So why? Yeah, okay. So revisiting our recommendations, I'm going to read them so that you have them easily in your mind, and then I'll go afterwards so that you can start, and I will go back to the recommendations. So please join the Mentimeter and entering the menti.com and use the code that you can see there. And while I'm talking, including the presentation of some take-home messages, you'll have the time to go and respond to the question, to this listing ranking. So what you consider to be the most important one or the higher priority one, you rank 1. The second is second, and so this means that at the end of the day, the top one will be the one that will have the lowest value. Okay, so it's clear for everybody that the first one, what you consider to be the most important one, you put 1. Okay. So coming to the recommendations, what they are. So the first one, recognize the key role of spatial planning in increasing resilience to extreme coastal and inland flooding events in a changing climate. Second one, maintain up-to-date flood hazard and risk maps and management plans. We heard a lot in terms of the importance of having reliable data, to have continuous database, to have good quality data. So what's the importance of these up-to-date flood hazard and risk maps and management plans? Third one, develop flood forecasting and early warning systems based on reliable data and modeling tools. The fourth one, improve the resilience of hydraulic structures through adequate monitoring, revision of return periods, and upgrading of critical elements. The fifth, relocate critical facilities and, where necessary, make long-term plans to relocate communities. The sixth, to promote water efficiency through innovative technological and non-technological solutions, including capacity building and certification. The seventh, facilitate safe water reuse and support research into treatment and renewable energy desalination technologies to address growing water scarcity. The eighth, reduce the unsustainable use of water, in particular groundwater, and ensure surface and groundwater quality protection. The ninth, increase the use of nature-based solutions and multiple benefit solutions through appropriate partnerships with clear lines of responsibility. And the 10th, develop water-oriented living labs and engage citizens, local authorities, industry and research institutions in the design of innovative solutions. So I'm curious to know what your thoughts are and what's your ranking. So take your time, but try to think as we used to say that women has this capacity of having two halves of the brain, one paying attention to that, and the other one paying attention to what I'm saying. Well, these two halves, sometimes one is imagination and the other is reality, so I hope that you don't split like that, just imagination but well, I hope that you can this double task together. So now, moving to examples of take-home messages that we made a note of. So Miguel Miranda told us that to cope with evolving climate and challenges, we know that we have changes in climate ahead of us. And what he says is that we profoundly need to change our lifestyle. So I think this is something that at least I took in my mind, and not only me. The other thing he mentioned that also, at least for me, is a take-home message, is we should carry out flood or other water-related extreme events drills. So we should carry out drills on flood or other extreme events, similar to what we do to fire drills or seismic drills. So I think this is also an interesting idea to take home. Rui Taborda and André mentioned that to reduce coastal risks, we need to consider a range of solutions. Avoidance, relocation, soft and nature-based solutions, improved of traditional solutions. But in any case, the first solution to consider is really to avoid risk through appropriate territorial management. So again, I think this is a strong message. Sorry for saying I believe, but it's not I, it's a we, it's a long, is I, sorry for the abuse. I agree, this is a take-home message, but this is a collective work. Overcoming water scarcity requires demand management and water conservation, efficiency measures in the urban, agriculture, and industrial, as well as the integrated and rational use of both conventional and alternative water sources. Water reuse and seawater desalination are on the table. So this came from Clive, and also from the other debaters in the water scarcity roundtable. Also from the same session, measures to ensure the drinking and reclaim water quality from source to tap are really needed. We need to work on that. And the fit-for-purpose treatment for safe, efficient, and cost-efficient water reuse was a strong message from Valentina that we also need to take into account. We cannot just go one size fits all. It's really important to look for fit-for-purpose treatment, ensuring these aspects. Some more. The more stringent discharge requirements to come with the revised Urban Water Treatment Directive will make water reclamation for reuse more competitive. Another take-home message that we took is risk is part of life. Difficult decisions should be taken before they are needed. Machine learning and real-time flow prediction is important. Change the paradigm, water management involving all stakeholders. We need to change the paradigm. Several speakers refer that reclaimed water storage is key for water reuse, and accurately modeled managed aquifer recharge may be part of the solution. So this issue of the managed aquifer recharge that we keep listening these 2 days in many interventions. There was a very interesting idea that came from the water scarcity roundtable. This, at the end of the day, we have one water to manage, one health to manage, and we cannot afford just looking at one specific type of water. We need to look at the water as one water, as Alexandra Serra mentioned, and that was then further discussed in this roundtable. One water, one health. Water smartness. This came and came and came recurrently. Of course, we need to be more intelligent in the way we use water. So we need to go, all of us, very much engaged and committed to water smartness. Another message, digital twinning, for instance, the digital twin ocean, should be important components in out and over to tackle extreme water-related events and for water governance in general. This is from Jan. Satellite-based Earth and ocean observation should be better integrated in our scientific advice support and monitoring of national and EU legislation and policy decision finding, again from Jan. Ricard Rigo brought us this message, integration of the most updated scientific knowledge in operational water management. This issue of the atmospheric rivers that we haven't been paying as much attention as probably they deserved, as he showed, they are behind the most frequent extreme events we had in terms of rainfall and floodings. Coastal regions, estuaries, are linked oceans and sea to freshwater systems. In this context, for the European Union, it's really important that scientific advice helps to further integrate and harmonize legislation underpinning freshwater and marine governance, namely the Water Framework Directive and the Marine Strategy Framework Directive. So this is something that I provoked Adrian saying, so we have the feeling that there is a kind of gray area that is not duly covered neither by the marine directives nor by the inland legislation, and he agreed and then rephrased the sentence in the sentence that you see here. Another take-home message that we took is the Portuguese legislation on inundation plans, inland estuaries and coastal areas, should be revised. It's very important that it's revised because it currently doesn't, the current version doesn't take all the main drivers into account. This was raised by André and then stressed by Elsa, so from the coastal areas and the inland areas viewpoints. Another message, many estuaries will experience dramatic change associated to sea level rise, so we cannot forget that. This is important. Coming to Zé Pedro again, professionalism versus personal interest is one of the most challenging issues for low probability and huge consequence risks, and this is something that we need to also to address and take into consideration, see how to manage this difficulty with due communication and try to anticipate the possible risks of this nature, so that it's a collective decision and not the guy who is on duty on the middle of the night of a Saturday having to make these difficult decisions. So these are the examples that I had. I don't know whether in the meantime you had the time to reply to Mentimeter. I hope that you did. And I'd like to have some quick reactions to that. So I'd like really to challenge you. I know this conference, luckily, has been overwhelming in terms of information. I think we had much information. We need to digest it. We need some time to digest. We are going to ask to all the presenters whether they don't mind providing the presentation so that we can share them on the web so that people can see, so that you have the opportunity to re-see and digest. But nevertheless, I'd like to know whether you had already thought, oh, this was in my mind, this is a very important take-home message, something that we didn't capture to this, and we would like to see here in this listing in some way. So you are overwhelmed, tired. Yeah, João.
I will share with you what I was saying to Rui, is that really I am overwhelmed with so much information, but nevertheless, there were some key points for me that were not fully or properly addressed. For instance, we will be now facing the new Urban Wastewater Treatment Directive with very, very stringent limits for discharge. And I have a bullet there that this will make water reuse more competitive. But nevertheless, that increase in the discharge requirements has to do with water scarcity again. Because the receiving water bodies have no dilution capacity or have reduced dilution capacity. So we have to improve everything in terms of quality for the nutrients that will trigger the eutrophication and the micropollutants. And it's very important that we do, as Valentina has shown, that we do try to find new solutions. And at least for me, we could have discussed a little bit more on that solutions, on those solutions, and new adsorbents, new low pressure membranes, something to prevent the particles in the water. So those are very, it seems like a molecular size or a molecular level, but they do make all the difference overall in the success of this management of water scarcity. So that was my final input.
Thank you, João. So I don't know whether, Catarina, whether you can see the results of the Mentimeter? I'm going to explain to you. I have been spending all day calling Joana Catarina because João Rosa asked Catarina Silva to support us with the Mentimeter. So her daughter got sick, as apparently everybody got sick around these days. So she couldn't come, and I asked Joana for her support. So I have been calling her Catarina all day. So sorry, Joana. She's Catarina now. I say. My
sister is Carolina. We are all.
So. So I hope it's only today. I hope that tomorrow I resume the Joana name. So this means that, this is the reply. So you already, the most voted is the first one? So this means that TANS is the most important? No. The first is the most important? Okay. So the most frequently ones, okay. So reduce the unsustainable use of water, promote water efficiency, increase the use of nature-based solutions, recognize the key role of spatial planning, so improve the resilience of hydraulic infrastructures, develop flood forecasting and early warning systems, facilitate safe water reuse, maintain up-to-date flood hazards and risk maps, relocate critical facilities and long-term planning, and develop water-oriented living labs. So I think it's interesting to look at that. Of course, we need to look at these replies critically, even because, well, some of you perhaps said, oh, this is a first range of things that are more important, these are less important. So, of course, these votes always need to be, taken into account. But anyway, thank you very much for this. I think it's interesting, and we'll share with you these results as well. So I would perhaps invite the president of LNEC, Laura Caldeira, to move, so that we move to the closing itself. And maybe while Engenheira Laura Caldeira comes up, I would start as chair of the conference just with my final words, and my final words are acknowledgement words to all of those who make this conference possible. So first of all, to all attendees. Of course, without the attendees, those who are here and those who are following via streaming, this conference wouldn't be effective. So thank you very much to all of you who are here, to everybody who has been here over these 2 days, and for those who are following on streaming. Of course, we are much grateful to all the keynote speakers and the R&D institutional representatives. You did great, you did a major contribution, so as chair of conference, I'm really most grateful to all of you, to all the roundtable participants, and of course to my colleagues who were moderators of the session. So these are the first acknowledgements I'd like to make clear. We are also very much grateful to our partners, and particularly our strategic partner, the municipality of Lisbon. They did a wonderful job in many regards, so with the image, with the sponsoring, with the ideas, with participating. Well, they have, I don't know, I am unable to list because they were really partners. So we were working together all the time. They were great, so we are really happy with this partnership. I think it's really a long-term partnership that's going to continue to work very well. We had many other supporters. We had the Horto do Campo Grande, who supplied the plans. We had the six associations, not 5, the 6 associations who are the water-related associations who are here. APRH, APES, BAEPSA, Liswater, PIANC, and the Portuguese Water Partnership. We are much grateful to FCCN, who helped us with basically all the videos that you saw today and yesterday. They helped us making the videos. Águas do Tejo Atlântico, who provided the Vira beer that you had the opportunity to taste yesterday, and to Junta de Freguesia de Alvalade, who sponsored the wonderful music. Those who were here, who weren't here yesterday, you missed a masterpiece of music. At least in my view, they were great. So we are very much grateful to them as well. And then it's a long list of people. I'd like to again acknowledge again the board of directors of LNEC, and particularly Laura Caldeira, for having challenged us to move from a small celebrations national conference to the international conference, and saying you need to go ahead. And I was saying, but we have little time to do an international conference, and you need to go ahead. So thank you for the encouragement and for the challenge that you made, and all the support during all the course, and also to the secretary that provided some assistance in the meantime. to my colleagues, to my peers, heads of department, that also provided very good ideas during the course of the organization. To all the CML, to the municipality team, especially to Catarina Freitas. She was great. In fact, well, now she's suffering in pain due to the accident she unfortunately had yesterday. She did great. I really would like to give her a big hug. I'm not going to give her a big hug because she wouldn't like to have a big hug nowadays. She would cry in pain. But she was great. She is great, and she's really a great asset for the municipality and for all of us. I mean, for everybody. I'd like to acknowledge the LNEC Organizing and Program Committee members. They are sorted in alphabetic order here. So Alexandra Carvalho, Anabela Oliveira, Celina, that helped us until August, Eric Didier, José Manuel Catarino, Luís Portela, Manela França Martins, Maria da Conceição Santos, Maria João Rosa, Natália Lisboa, Rita Morgado, Teresa Viseu. I'd like to thank all the department's team. You've been great. So I'm really, you know, I go for this week and I feel so happy. So I feel really privileged of having this team, working for this team, with this team. It's really a privilege, and I'm so much grateful to the whole DHA team and, well, to LNEC team at Broad. But in particular, I'd like to acknowledge Meric Louro for the website, Margarida Afonso. They are in alphabetic order, not for the functions, mostly. Margarida Afonso, Silvia Amaral, on behalf of those who contributed to the DHA activities team movie. Sorry, the movie that we saw yesterday. I don't know exactly who contributed, so I thank Silvia on behalf of those who contribute for the movie. Teresa Leitão as leader of the celebrations team. For those who assisted in the organizing and making it possible the technical visits team, so Álvaro Ribeiro, António Muralha, Elsa, Ian Andrea, Joana Forte, Ru Reis, Rui Viegas, and maybe somebody else. I'd like to very specially also to thank the colleagues from the convention center. Rita Morgada in particular, she was really amazing, always, well, very collaborative, very efficient, very professional, and all the team associated to her, so Fernando Tomás, João Pires, Miguel Rosado, Tiago Rego. I'd like to also to thank the IT support from LNEC, Rui Monteiro, Cristina Borges, to all the postgraduate students that are here. On behalf of Catarina, I'd like to thank all of them. So Ana Moura, Carolina Gonçalves, Carolina Martinez, Henrique Matos, Joana Carneiro, Larissa Freitas, Marta Palitos, Pedro Tavares, Sofia Charrua. You did great, so it was really a great asset for the conference as well. If I forgot to mention someone personally, my apologies. It's easy to forget when there is a big list. If I missed some name that I should mention in particular. So everybody, I'm really grateful to everybody who made this conference possible. And having said that, I convey the word to...
My role is very simple. Helena Lerg has said it all, so I only have to add Artur Vieira Pinto for his support also. Thank you very much.
Oh.
It's mine.
Oh. So it was good that I apologized in advance, because I'm sure I made tremendous mistakes. And
no problem.
Artur Vieira Pinto, you has been great. So from day one, we exchanged, I don't know, hundreds of messages. He has been great in... Sorry for that. But the last are not least...
You leave that for me, so it's very good.
I'm really grateful to you. So
thank you
my
very much for the presence of all speakers. And I have a special thanks to the organizing committee for this organization that is went so well during all these days, and I wish to invite you for next year. There will be another LNEC Lisbon Conference 2024. It's also about a subject that you are interested. It is about urban risks and societal resilience, and I hope to see you here next year. Thank you very much.
Vou lá ao pé do Artur Vieira Pinto. Não digo que só faço as neiras.
Não tem problema, Helena.